Send a request to x.com/natgeo. Status 200. Looks fine until you check the body. JavaScript is not available. That's X's entire defense in one sentence. It doesn't ban you. It doesn't block your IP on the first request. It just refuses to render. The whole site is a JavaScript application, and a plain HTTP client gets an empty shell with an error page. So we route the request through scrape-do. Grab your API token from the dashboard and flip 2 switches. Render because the entire page is JavaScript. And wait selector, pointed at the tweet article element. Block resources stays on by default, which keeps credit costs down. Run it again. Status 200, and this time the HTML coming back is the real, fully rendered page. Here's why wait selector matters. Watch how X actually loads. First, a black screen with nothing but the logo. Then the profile shell. And only then, in a second pass, the tweets themselves. Render alone fires when JavaScript executes, which means you can scrape too early and get a perfectly rendered, perfectly empty page. Wait selector tells the browser, don't return anything until an article with data test ID tweet exists on the page. That one parameter is the difference between 5 tweets and 0. Now, selectors. Open DevTools, and the first thing you see is chaos. Class names are machine-generated noise. Random strings, regenerated on every deploy. Anchor a scraper on those, and it dies within a week. But look closer, and there's a second layer underneath. Data test ID attributes. Username, tweet text, tweet photo. These stay, because Twitter's own end-to-end tests depend on them. Anchor on what QA anchors on. The extraction loop selects every article with data test ID tweet, then works through each one. Profile name and handle live in the same username container. The timestamp is a time tag carrying a full ISO datetime attribute, and the tweet URL hides in the parent anchor of that time tag. Join it with x.com and you have a permanent link to the post. Tweet text sits in its own data test ID node. Extract it with a space separator because the content is split across nested spans. With emojis as inline images. Photos come from tweet photo nodes. And link previews, the embedded cards, live under card.wrapper. All 3 are optional, so guard everyone against missing elements. And here's the best trick on the page. Every engagement metric, replies, reposts, likes, bookmarks, views, sits in a single area label. 42 replies, 280 reposts, 1,453 likes, 159 bookmarks, 894,439 views. One attribute, split it by comma, take the first token of each part, and you've parsed 5 metrics in 6 lines of code. No digging through nested spans. No abbreviated 1.4K values. Run the full script. 5 tweets extracted, the default profile view, and saved to CSV. 12 columns per tweet. URL, author, handle, timestamp, text, images, embedded link, and all 5 metrics. Real numbers, machine readable, ready for a pipeline. Scraper number 2, the profile itself. Same request, same 2 flags, only the targets change. Header image and profile picture come from anchors matched by URL pattern. Name and the verified badge sit under username. Bio, location, website, and join date. Each carry their own data test ID. 1 page, 10 fields. Following and follower counts come from 2 anchor links. Strip the label text, keep the number. Bundle everything into a dictionary and dump it as JSON. National Geographic, verified, 178, following, 27.7 million followers, joined November 2008. Last one, trending topics. They don't live on the home page. They live in the sidebar of tweet pages. Point the scraper at any status URL. Switch the wait selector to data test ID trend and read 3 spans per card. Category, trend name, and context. 4 trends, straight into a second CSV. 3 scrapers. 1 selector strategy. Render plus wait selector. X's JavaScript wall. Bypassed without a single header hack. Full code is on GitHub. And scrape-do gives you 1,000 free credits to start.